Welcome to AVL's Reimagine Mobility podcast series. I'm super excited to have Phil Stephenson from PACCAR here with me. Thank you, Phil, for joining me. And maybe, Phil, before we start kind of reimagine mobility here together, and certainly with a focus on where you and PACCAR is operating in when it comes to the mobility space, give us a little background of what you've done, where you're coming from, and what today your responsibilities are at PACCAR, and then let's jump right into it.
Sure. Okay. Well, I started my career in diesel engines and thermal management and simulation and spent a lot of time there. I've been a visiting scientist at Daimler Research Center during my PhD. I worked for AVL for a short time. I was chief engineer at Bear America. I was director of engineering at A123 Systems, working on lithium-ion battery systems for heavy duty. And I've been general manager of the PACCAR Technical Center for the past 12 years.
Excellent. Perfect. So wide variety of experiences, heavily in simulation. You work in batteries. Let's take that clue and jump right in it. What do you see? Because you and I have talked about this over the last many years, right? This push that we see globally now, clearly in the U.S. as well, over the last 3, maybe 4 years, of electrifying as much as we can. Let's leave passenger vehicles out. Let's leave medium-duty vehicles out. And let's talk about heavy-duty trucks. What do you see? And again, with the theme of the podcast, Reimagine, what do you reimagine? What do you see in the future happen as it relates to electrification or propulsion systems as a whole, hydrogen including fuel cell, whatever? What do you see, Phil?
Yeah, well, I think it's important to think about what's driving all this, and that's a big push globally to reduce CO2 emissions. We more or less solved, or 99.9% solved, the criteria of pollutant emissions from internal combustion engines. So we're looking at CO2 now, and a lot of the methodologies you mentioned, whether it's electrification, whether it's hydrogen fuel cells, even hydrogen combustion, they're all different approaches to eliminate CO2 from the tailpipe of all vehicles. But of course, we're focused on medium and heavy duty vehicles at PACCAR. And it'll be interesting to see what combination of technologies wins out. I think you have to look more broadly than the individual vehicle, more broadly than fleets. You have to really look at the energy system as a whole. How's the energy being generated? How's it being transmitted? How's it being stored, whether it's a liquid or in a battery or as a gas? And what's the efficiency of conversion along all those steps, all the way out to putting power down to the wheels that drive the vehicle on the road? So there are a lot of challenges to be solved. And we're living in a time in a lot of countries and jurisdictions where technologies are being selected, maybe not taking that whole system point of view in mind, maybe looking at a smaller piece of the puzzle. And I think over time, we're going to realize that we need to look a little bit more broadly to make the best overall decision as engineers and policymakers.
Phil, it's a great point, I think, and I'm going to call it out, right? We have government and regulators on a local, on a state, and maybe even a federal level here in other countries as well, that are sort of coming in and saying, I like what I'm hearing that I just saw in this presentation on, let's just say, hydrogen. I'm going to legislate it now. And then us engineers are kind of looking at each other and like, well, hold on a minute. I don't think that's necessarily the best way of doing things. That's sort of where we're at. What do you see, generally speaking? Again, not pointing the finger at anybody, but what do we as an industry, leaving government out for a moment in the regulations? I know that's a big piece of it, but let's leave that out. What are we doing wrong? What can we do better, Phil, as an organization and as an industry in focusing on the sustainability of our planet, yet still do what we need to do for our customers, in your case, for fleets, moving of goods, etc. Share a little bit of your vision there.
Yeah, so I'll speak from the point of view of a truck manufacturer, so I'll leave out all the other modes of transportation. I will say briefly, of course, it makes sense to use the most efficient modes of transportation and make sure the interfaces between ships and trucks and rail and whatever else makes sense. But focusing in on commercial vehicles, first of all, we need to be offering solutions that meet the requirements we have today. We can have a long discussion about what the right way to do things is, but in the meantime, we have customers that need to move goods and need to satisfy demands of their customers. So, I think we need to continue to work on all of these different systems. First and foremost, the internal combustion engine is going to be the solution for a good portion of our customers for a long time forward. We just got diesel to the point we got it, and it is still the system we know how to operate. It's still the infrastructure that we have optimized. We know how to make fuel, move it around, burn it efficiently and cleanly, and we can't lose sight of that. So now we're talking about other future powertrains. I'll leave the discussion about internal combustion for another day. But as I said, our strategy at PACCAR is really to look at, hydrogen. How do you use it to make energy? Do you put it in a fuel cell, make electricity, and essentially drive a hybrid vehicle? Do you burn it in an internal combustion engine? I think the scorecard on that really has to be related to the overall efficiency at vehicle level and the availability of infrastructure to get hydrogen and put it into your vehicles. Similarly, on electrification, of course, the big pressure these days is on battery electric vehicles or plug-in hybrid vehicles that have relatively large batteries. And we need to also be looking at whether it makes sense to put all of our focus on very large batteries, which are currently quite heavy, quite expensive, or if we got a fixed amount of batteries, would it, just as a thought experiment, would it make more sense to hybridize everything? Put a small battery on every engine, on every internal combustion powertrain, or does it make sense to maybe electrify 10%? Good thing is we have all the tools. We're engineers. We know how to do system analysis. And I think, as I said, our task is to keep providing solutions, but at the same time, provide good data to our decision makers to help them make the right, decision in terms of what they really want to do, which is to minimize CO2 and, improve conditions here on our planet.
Yeah, very good. Got two follow-up questions. One, at PACCAR, you're truly I would say a global operator, right? A global corporation. What do you see different, if anything, what's going on in Europe and what you have to do in Europe to what you just shared here that you have to do here, right? At the end of the day, you have a customer that has a need and you need to suffice this need with as much of CO2 reduction, emission reductions, whatever you can do to preserve the environment, do what you need to do from a legal perspective. But what's some of the differences maybe for some of our viewers and listeners that are not familiar with between Europe and here?
Yeah, well, I can point out a few. So on the hydrogen side, one thing that I didn't know until fairly recently, the last year or so, is in the United States, hydrogen combustion is not considered, or at least in California and the CARB states, it's not considered zero emission in terms of CO2. That's because there's a little bit of CO2 that can be generated from the lube oil in the engine. And that's because you are doing combustion. You have combustion chamber temperatures, which can create a little bit of NOx. And although you can treat it in after treatment, you never get to zero. So that's one difference. Whereas in Europe, in most jurisdictions, hydrogen combustion is considered zero emission technology. On the battery side, I think we've got a lot of similarities. We've got applications for full electric vehicles and for hybrids, certainly. There are differences, though, in how plug-in hybrids are handled in terms of credits, in terms of zero emissions credits. So it turns out in Europe, as a plug-in hybrid electric vehicle gets more favorable treatment for credits than it does in the United States. And then I guess the third point is, and maybe the most important, is the boundary conditions are quite different. You have zero emission zones in cities where vehicles that can operate on diesel most of the time outside the city and then go to a zero tailpipe emissions mode are probably getting more interest in Europe at the moment than in the US. And then add to that, of course, the usual things we face with any kind of powertrain. We have higher speeds in the US than in Europe. We have probably a wider range of temperature conditions, altitudes, grades, and that just drives, different designs.
Sure. And distances maybe too, right, of what we drive versus what Europe drives. Yeah. So, and then the follow-up question again to the question before, your answer previous to the one we just answered here. I hear a lot of people when we talk about maybe for heavy-duty trucks, it's not the right way to go electric. They mention companies that have tried and then sort of failed, or I mentioned those, right? And then the feedback is, but look at what Tesla's doing. Tesla's the most successful EV passenger vehicle manufacturer. They make money. They sell hundreds of thousands of vehicles globally now, right? They're going to come out with a truck and they're going to show everybody how it's done. What do you respond to that?
Well, first of all, I do applaud their success in light duty, and they've really shown that it's possible. They've done some things outside the vehicle around infrastructure as well. Their charging network is impressive. They've more or less set the standard for light duty charging interface. Everybody's adopted that. However, they're still subject to the same physics that we all are, and so they, I'm sure, are facing the same challenges that any heavy-duty manufacturer is with a full battery electric vehicle that weighs 40 tons, which has to travel maybe 500, maybe more miles, so 800 kilometers on a single charge, which needs to have limited charging time. All of those things generally will drive a much heavier vehicle for the time being. And so I am sure they will meet those challenges as we're all trying to do, but they're going to face challenges in terms of the amount of payload that could be carried on a vehicle which has enough battery to meet that range. They may very well face challenges with fast charging. Fast charging is, I always like to put it in terms people can think about. We talk about charging at 1 megawatt being sort of the holy grail for fast electric vehicle charging. Depending on the amount of flow you've got at your diesel pump, the equivalent charging rate, if you want to think about it in terms of power, is somewhere between 10 and 30 megawatts when you're tanking diesel. And that's really the benchmark we have to compare to. So that's going to be a challenge. I also think they've made an interesting decision to go after long haul first. We are certainly approaching that market, but we're also approaching the ones that maybe are better suited shorter term for electrification, like pickup and delivery. Refuse is a very interesting one. Regional haul, port drayage. There are a lot of cases where one has a mission profile which has a lot of idling, let's say, a lot of regeneration opportunity, shorter routes, up to say 100 to 200 kilometers. And that tends to drive less battery mass and the ability to do this with less compromise compared to long haul.
One thing, Phil, related, and you alluded to it, and the weight of those vehicles, right? How heavy they are. I talked to somebody the other day, and we kind of brainstormed a little bit, right, about the infrastructure, because we were kind of complaining about our Michigan streets, right? You've been here, pothole is about as normal here as somebody with a Michigan t-shirt running around, right? Michigan University t-shirt running around. So what do you guys, when you guys look at these trucks, is there somebody also addressing that, hey, if suddenly everybody drives around with an electric heavy-duty truck that still needs to carry a full load, is our infrastructure. I'm not talking charging for a moment, because everybody talks infrastructure equals charging. Now, infrastructure is a whole lot more. When we're talking about our street systems, right? Are we talking about this? Is this something you guys are talking about? Because I hear very little about it.
Well, we talk about it all the time because it turns out even for conventional powertrain vehicles, there are different bridge laws, for example, that vary state to state. If you come out here to the west where there are a lot of logging trucks, you'll notice they have very long tongues on their trailers between the lead vehicle and the trailer, and that's directly due to bridge laws. You'll see some vehicles will have what we call a set forward front axle, where the steering tires are very close to the bumper. Others will have it set further back. You may have tandem axles, you may have dual steer axles, and all of that really is about weight distribution for the payload that the vehicle's carrying. In terms of electric vehicles, at present, in some cases, they will get a minimal allowance for additional mass. So in general, on-highway trucks are limited to 80,000 pounds. There's an allowance for electric heavy-duty vehicles to go to 82,000. In terms of the wear and tear on the road, that's a couple percent. It's probably fairly minimal. The question will be longer term, whether there are allowances made to go even more than that. And then I think what you're talking about in terms of infrastructure effect becomes more significant. But right now, it's basically just a penalty on payload that's accommodating the additional mass. And just to give people listening in on this sort of an idea, if you've got an 80,000 pound gross weight vehicle with a range of, say, round about 350 miles, you're going to pay about a 9,000 pound penalty compared to a diesel powertrain to have a full battery electric powertrain. Configurations will make that number go up or down, but it's in that ballpark.
So it's fair though to say, Phil, that from a fleet owner, right, if he or she decides to move over, there is an economic impact to, I now have, quote unquote, 9,000 pounds less of goods to deliver that I now may need to have a second truck or a third truck, whatever it is, to haul, right? That's a fair statement.
Yeah, I mean, it depends a lot on the cargo one's hauling. We talk about fleets grossing out or cubing out. So if you're carrying steel coils from the mills in Indiana, it's different than if you're carrying potato chips. But certainly if you're hitting your weight maximum, yeah, there'll be an impact.
Yeah. Let's go back we reimagine mobility here. If I ask you, Phil, and again, we've talked about this too over the years since we know each other. We've talked about when do we see electrification come, and here it is. We talked about hydrogen. We haven't really talked about e-fuels. I think that's a bigger topic in Europe maybe than it is here. There's, again, an infrastructure challenge associated with it. But if you look at just in general, outside of electrification or outside of alternative propulsion systems next to diesel, anything and everything, what excites you the most if you look 5 years forward, what you see happening, again, in the industry you and PACCAR are in right now? What do you see?
Well, I'm not sure if this is going to answer your question directly, but I see the infrastructure supporting electric vehicles and electric vehicles developing side by side out of necessity. I'm seeing a lot of progress in the understanding, at least, if not the addressing of the need for a better electrical charging infrastructure. We are in discussions, and as part of our Super Truck 3 program to the Department of Energy, we're in discussions about microgrids, for example. So providing the charging power for all of these chargers that we're going to need to have without relying on the grid to provide that power in real time. And I'm encouraged by the companies that are working in that space, by the companies that are working in the high power charger space, because that difference in time between the power being available and the time that it gets to be on the vehicle is critical for uptime. And that's what, really drives the profitability of our customers. So that's one topic. I think there have been a lot of advances made in hydrogen as a fuel, whether you put it in a fuel cell or an engine. And, you did mention e-fuels. It's encouraging to see what's being done to create synthetic fuels, which can be transported, tanked, burned, just like any other fuel. Um, I recently had a discussion with a colleague that works for one of the oil companies, and he he sort of damped down my enthusiasm a little bit on e-fuels for highway transportation because he pointed out if aviation is going to go zero net carbon, they're going to soak up a lot of those e-fuels. They have to. They can't bear the extra weight of batteries like we kind of can in ground transportation. So while I'm excited about it, I'm not sure how much of a play that's going to be in heavy duty or medium duty transportation.
And if we talk about maybe instead of 5 years out, Phil, 5 to 10 or maybe beyond that, is solid state batteries the holy grail as it's sort of looked at for passenger vehicles, like as it relates to weight, as it relates to size, as it relates to driving distance, as it relates to charging time, everything that we're currently worried about? Is that the same thing for medium and heavy duty trucks that you guys are in, or is this is one piece, but there's still others like the microgrid, which maybe I want to come quickly afterwards back to?
Yeah. Well, I mean, a lot of people like to say, there have only been four revolutions or four innovations, big ones in batteries in the last 160 years, lithium ion being the fourth one. I think that in terms of energy density, things like solid state batteries, things like lithium metal anodes, for example, they do pose, some promise. But like any battery technology, we're going to have to, see the validation results, particularly for heavy duty. We're going to have to see if they could provide the number of charge discharge cycles that we need. We design trucks to have, 1,000,000 miles, 2,000,000 miles of life, depending on the application. And we expect, right now it's maybe an expectation more than a reality, but we expect that the battery system will live the life of the vehicle. So, when we look at battery technology, we're looking safety, of course, we're looking at power and energy density. We're also looking at life, and you really have to meet all of those goals before you say this is a technology which is going to move the needle for us. So, yeah, solid state I think is very promising, but it's probably on the 5 to 10 year horizon before we see it as viable.
Now we see that as well in our studies and our simulations and working with some of those companies. Maybe two more questions, Phil. One, you mentioned microgrids, and that's always comes back to the infrastructure, which definitely is a challenge still in this country. I mean, I just finally bought my first EV. I had to convince my wife because she's never seen a charging station in a 10-mile radius around us. She's like, well, what am I going to do? Different story, but this microgrid that you spoke, do you believe, talking to those people that you have, I've talked to some of them as well, do you believe this actually will solve the infrastructure problem, not only on a private level, but on a different level than private companies figuring out how they can, plug into the grid that it's owned by, DT Energy in Michigan and others, Duke Energy in the South and other places? Do you feel this could be the missing piece, so to speak, to accelerate this infrastructure?
Well, I think the solution's going to have a lot of pieces, but I think microgrids are potentially a very important piece of it. The ability to buffer the demand from the supply, I think, is very important. And microgrids are one way to do that. But so are bidirectional chargers that allow vehicle to grid connections under certain situations. Those are technical solutions, and there will need to be commercial and policy solutions that go along with that. For example, if I have my F-150 Lightning and I can plug it in at my house, why do I want to let that power the grid? I know it's more watt hours of throughput on my battery pack. What am I getting back for that? Just as an example. And so these things are all going to have to make sense together. But going back to your question, I think microgrids are probably one of the most viable concepts we have right now for decoupling some of this peak demand we're going to have due to charging from the ability to generate transmit and distribute the power over the grid.
And the last question, and maybe you already answered it or alluded to it with your F-150 comment. I don't know. We'll see. Phil, what's the next car you're going to buy and why?
Well, I bought my first EV 3 years ago, and it's got a 10-year, 160,000-mile battery warranty on it, and I intend to use all of that warranty. So the next car I'm going to buy is going to be a little ways out. I would love to think that it could be a passenger car version of one of these powertrains we're talking about, maybe a hydrogen-powered vehicle. I don't think I'll ever probably, unless it's not available in the platform I buy, I don't think I'll ever buy a pure ICE vehicle again. If I could get myself a diesel-electric hybrid SUV someday, I think that'd be pretty cool.
Okay, perfect. Appreciate your answer. Thank you so much, Phil. We're together here, Reimagine Mobility, share your vision and from your industry. Super exciting. Very thankful for your insight. Thank you, Phil.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.